Hello friends, welcome back to my channel. Today we will discuss dimensioning rules in engineering drawing or engineering graphics. So in engineering graphics, as we all know, is a language of engineers, so that they can convey the messages through drawings from one person to another. If you have represented the shape correctly, it is not sufficient. You need to give the dimensions and the details of the shape as well. Therefore, dimensioning is a crucial part in engineering drawing. So we'll see some rules along with some examples. First, we will see what is dimension and what are its features. So as I just now told, a detailed drawing is expected to provide not only the complete shape description of the part, but also furnish the size description. This is provided in the form of distance between the surfaces, location of the holes, and various other features. These features are illustrated on a drawing by use of lines, symbols, figures, and notes, and all together it is called as dimension. We will see all these things in the coming slides. So what is a dimension? It is a numerical value expressed in appropriate units of measurement and indicated graphically on technical drawings with lines, symbols, and notes. This is a formal definition of a dimension. So only thing you need to understand is you should understand what is dimension. No one will ask you what is dimension. You should understand the concept. Now the units of measurement. The most commonly used unit of length is millimeter. So all the dimensions will be expressed in millimeters. So we don't need to represent mm or millimeters along with the dimension. But if you are going for another units, that means meters, centimeters, or decimeters, etc., you need to specify that one. Otherwise, everything is in millimeters. And angles are shown in degrees. Symbols are incorporated to identify specific geometry wherever necessary. So symbols will help you to identify the geometry. So you can represent square, circle, etc. Now notes are also provided to give specification of a particular feature or to give specific information necessary during the manufacturing of the object. So some surfaces need special machining, surface smoothness. That should be added as a note. So all these altogether will form the dimension. Now this will be a drawing sheet. So this is your paper border, and inside that you will draw the margin where this is 20 mm, this will be 10 mm, 10 mm, and 10 mm, and right side bottom you will have the title block. So how to draw a title block and what are its features, we will discuss in a separate video. And in the other part you will have the drawing. This is just a drawing, and a dimension is shown, and below that one you will write all dimensions are in mm. This is just a sample. All dimensions are in mm. So the meaning is that whatever, if this 50, along with this 50 there is nothing, no unit. The meaning is that it is in mm. All dimensions are in mm. That is the meaning. Now what are the informations conveyed using dimensions? So using dimensions you can provide the distance, you can provide the size and position of the holes, grooves, and other features, and details relating to manufacturing, etc. So first of all, this is a location. This is a rough dimensioning shown. Okay, this is a rectangular sheet. Inside that one there is a hole. So now you see 15 mm to the right and 15 mm to the down. You can find the center of the hole. So location of the hole is specified. Now using this dimension, you got it is a hole of diameter 5 is used to represent diameter 15. So now you have written here hole. So note is also provided. So size specification, 5 symbol for diameter. Now what is the size function? What is the size of this edge? That is 30 mm. Now manufacturing detail. So this surface, that is about this surface. This surface should have a roughness of 0.5. So manufacturing detail is also provided. So all these things will be included in the dimensions. Some may not be present at all time, In all drawings, manufacturing detail may not be there. Whenever it is necessary, it will be provided. Now the leader line rules. This line is called leader line. Okay, whatever you have seen the last one. All these lines are leader line. So leader line is never drawn horizontal, vertical or curved. Okay, so this is wrong. This one is wrong. This one is also wrong. It is curved, shown as a curved one. But it should be like this. See, 30 degree, not less than 30 degree. It should be greater than 30 degree and a horizontal one. And above that horizontal line, you should write the note, roughness 0.5. This is wrong, and horizontal and vertical, that is wrong, and curved way of representing, that is wrong. When pointing to a circle or arc, it is drawn radially. That we will discuss in the coming slides. So that is a rule about leader lines. About dimensioning lines. A dimension line is placed at least 6 to 8 millimeter away from an outline and from each other. Now we have, this is our actual area, this is our rectangular sheet with two holes inside that one. Now we are going to represent a dimension, so that, see, you have provided two end lines here. In between, then you have provided a line and an arrowhead and an arrowhead, and you have written 50. Now the rule is that the distance between this surface and this line, that is around 6 to 8 mm, and this should extend up to 3 mm, up to around 3 mm. That is the rule. An extension line extends 3 mm beyond a dimension line. This is that one. Okay, 3 mm line, and a dimension line is placed almost at least 6 to 8 mm away from the outline and from each other. There is a dimension line rules. Next, about arrowhead. Now, just now we have seen arrowhead. So this is open arrowhead, this is closed arrowhead, closed and filled arrowhead, and in some cases oblique stroke is also provided. In most cases this one is preferred, closed and filled, and there is a rule, it should be 1:3. This length should be 3 times as the width. Not exactly, okay, you should practice in that way. So if you do like this, this is wrong, this one is wrong, this arrowhead is wrong. Why? Because its length and breadth is almost same. It should not be like that, sorry, it should be like this. Okay, the length should be 3 times as the breadth, that is here. If this one is W, it should be 3W, 3 times the W. So that is the arrowhead. That's about arrowhead, and arrowhead should be there at the end of the dimension lines, and it should touch the outline as well. Okay, so what it means is that, so you can see here, the arrowhead should touch the outline line. Okay, it should not be in any other way. Now we have another two types of systems of dimensioning. First one is aligned system. In aligned system, the dimensions are aligned with the entity being measured. They are placed perpendicular to the dimension line such that they may be read from the bottom or right hand side of the drawing sheet. The dimensions are placed at the middle and on the top of the dimension line. Next type of system is unidirectional system. In unidirectional system, the dimensions are placed in such a way that they can be read from the bottom edge of the drawing sheet. Dimensions are inserted by breaking the dimension line at the middle. These are the two systems, aligned system and unidirectional system. I will show you with an example. So the first one, this one represents aligned system. So you can see, you can read all the dimensions from bottom and also from the right side. Okay, so you can see, if this is a dimension line, above the dimension line and at the middle it is written 50. Here above the dimension line and middle you write 20. This one, above the dimension line and at the middle you have written 30, but you can read it from the right hand side. That is what is written here. It can be read from the bottom or right hand side of the drawing sheet. That is aligned system. Next is unidirectional system, that is read from the bottom edge of the drawing sheet. So here you can see all the dimensions can be read from the bottom side. Okay, so how it is drawn is the middle of the dimension line is broken and there you have written the dimension. So 30, so mark the difference between this dimension and this dimension. Here it is parallel to this line, but here it is parallel to the bottom line. Okay, and you have made a break and you have written here. Note down the difference between 20 and 60. 28 is shown like this, 28 is shown in this. You should follow either of this one. Do not mix and use. Okay, if you are following aligned, it will be better if you follow the aligned dimensional. Next, what are the elements in dimensions? So here you can see this is the dimension, this 50 is the dimension, and this one is the leader line that we have already seen, and this is the knot. That means about the hole, it is given 2 holes are there. So 2 holes are there with diameter 20 mm. That is a knot. Then this is the arrowhead. All these things you have discussed, and this is the dimension line. This one is the dimension line, and all this is our dimension lines. And these are extension lines. You can see here some extension also here. It should be minimum 3 mm extension. That also I think you remember. So these are the elements of dimension. Now, where can you place the dimensions? So dimension, you normally you can place it above the line. So if the space is very less, you can follow this one. That means the arrowhead should be outside that one and dimension inside. Or if it is very if the area in between is very less, then you follow this arrow and above and outside you can write 7, or you can put a leader line and write 4 mm if it is very small. So you can follow any of this one. Now how to do that angular dimension? The same thing. Okay, you can draw an arc, draw the arrowhead and mark 25. You can mark the dimension outside that one, and also if it is very small, you can use a leader line to represent the degrees. Another type is chain dimensioning. This is another way of representing chain dimension. So all dimensions are aligned in such a way that an arrowhead of one dimension touches the tip to tip arrowhead of the adjacent dimension. So you can see here 12, 8, 15, then 12. The overall dimension is placed outside the other smaller dimension. So overall is 55. That is also, this is called chain dimension. There is one more thing called parallel dimensioning. So you can see here the same thing is represented like this. This is 12, this is 20, 35, 43, 55. The dimension lines are parallel to each other and it starts from the first point here. This is called as datum. So from a datum, all the dimensions are described. That is called parallel dimensioning. So you should know the difference between chain dimensioning. The arrow to arrowhead will have a tip to tip contact, but here it will be a parallel. It will be all the dimension lines are parallel and it will have a datum as well to represent all the dimensions. Now combined dimensioning means chain dimensioning and parallel dimensioning are used together. You can see here 8 and 8. These two follows parallel chain dimensioning, and these 8 and 20 forms the parallel dimensionings from a datum. You can see the datum here. So that is called combined dimensioning. That also you can follow. Now examples of hole dimensions. So you can see this is a hole of 40 mm diameter. So you can represent it like this. Draw a line, put arrowhead and write 540. Another way is this is 20 mm diameter. So draw a line, arrowhead and put a leader line and write a knot 520. Or if it is very small, you draw a line, draw the arrow outside the circle and write a knot 550. All are correct. Now another case is 3 holes. You have 3 holes of same size. So what we can do is draw a line with arrowhead and use a leader line and write 3 holes of 520. That means these 3 are having diameter 20 mm. is just an example of dimensioning hole. Example of cylindrical dimension. So this is the one view of the cylinder. You can see with the circles of different diameters. So same thing has been represented here. So see, this is the outer circle, which is diameter 40, 540. The inner one diameter 30, again inner one 20, and these are the linear dimensioning 25, 25, 40, 60. That is parallel dimensioning. Here these two, there are two cylindrical measurements as well, 5, 60 and this one. So you can see this is the line, outer line, and this is the dimension line above that one. Here aligned system is followed because you can read all the dimensions from bottom of the sheet and right hand side of the sheet. Arc dimensioning. So in many cases you need to represent arc whenever nose, radius, etc. will come. Okay, so here you can see you can draw the arc, and you from the center of the arc you draw a line, thin line, arrowhead, and above that one you can write R20. The meaning is that this is an arc of radius 20 mm. Or you can draw the line, draw the arrowhead, and using a leader line you can write the note of R10, radius 10 mm. Or you can put the arrow here also. On the leader line you can provide the arrow, and here just a line. That is also correct. Or you can provide in this way as the leader line on the other side. Okay. Now spherical features dimensioning. In many cases there may be spherical features. So you can see here the figure C, there is a spherical feature here. Here also spherical feature. So you can write like spherical diameter 40 mm. So it represents that there is a spherical feature coming in the dimension in the drawing, and which is equal to 40 mm. It can be represented like this. That spherical is represented by the dimensional arrow, and using a leader line you can write this one. Next, this is the spherical shape, not a circle. If you write 550, it means that it is a circle, but S550 means that this is a spherical feature. Okay, that is a difference. Or you can provide this is also a sphere, not a circular hole. So you can provide a leader line and write SR12, meaning that it is a spherical feature of radius 12 mm. Now square dimensioning. So if you write a dimension like this, put a square and write 30, means that this is a square of, that means all sides are equal length. Or you can provide SQ30, or using a leader line put square 30 or SQ30. All are correct. This is how square dimensioning is made. Now the conical or tapered features. In many cases you will have tapering. Okay. So first case is you can provide the outer dimension, the longest diameter and the shortest diameter, and the distance between these two. Okay, that is one way of representing a tapered feature. Another one is you can provide the largest diameter and the distance between the distance of the taper, and also you can provide like this, a leader line and an arrow like this. That is not arrowhead. Okay, it is like this, and inside the box you represent the thing 0.2:1. That means the taper is 1:5. So that means when you move this much forward, how much is going down, how much taper is coming. Okay, it is represented in this way. Next one, you can provide the length of the taper and the shortest diameter and the angle of the taper, 11 degree. What is the angle of the taper? 11 degree. So in these three ways you can represent conical or tapered features in technical drawings. Now flat tapered features, there is a small difference here. One is this portion is flat, only this portion is tapered. So it can be represented by, so you can see this is the flat taper symbol. Okay. Before that one we used this one. This is taper, and this one is flat tapered. That means the half of that one tapered. And there you write 0.25:1, that is 1 by 4. So when you move forward by 1, how much you have the taper, that is represented by this one. Slope equal to 1:4, and what is the angle also, it is provided here. No, not angle, it is what is the slope, it is represented by 1:4, and the length of the taper you need to provide, length of the taper and the initial length. So this is how flat tapered features are shown in the technical drawing. Now a correct drawing and a wrong drawing. Okay, so the right side represents the correct drawing and the left side represents the wrong drawing. Okay, so you can see here in the left side drawing, you can see most of the values are coming inside the drawing, and it is very difficult to identify the features. But in the right side drawing, most of them are outside the everything. So you can see this 20 is here, but here the 20 is outside the drawing. So this R10, that means radius 10, it has been made here 520 in this way, and this 20 mm, this 20 and this 20 has been changed to outside one, and this 40, this is wrong, this is not a linear measurement, you need to provide 540 diameter 40. Here also see it has been changed to this one. Okay. Now the 25, it is coming inside the drawing. Okay. So now it is outside the drawing. Okay, you need to, so if you take this 20 mm individually, it is correct. If you take this R10 individually, it is correct. But the when you apply in a drawing, the drawing should not be affected by your dimensioning. Okay, so why you are giving dimensions? Dimensions are, you are giving the dimensions to make others understand or convey the message about the shapes, but you should not make it a complex thing. Okay, that is why the left side is wrong and the right side is correct. And these are the, already we have discussed, these are the symbols used in the dimensioning. Phi represents diameter, S5 means spherical diameter, R radius, SR spherical radius, and this one square, cylinder or cylindrical, PCD pitch circle diameter, that is for gear, EQSP equispaced. These are rarely used, only in specific drawings. LG long, CSK countersunk, C bore, counter bore, SF spot face. This one for conical taper and this one for flat taper. M for metric thread, that is for the, there is metric thread and English thread. So these are the symbols used in dimensioning. I think it is clear for you about the dimensioning in engineering drawing. So all these rules should be followed in your drawings. So thick line and thin line should be, you should be able to differentiate in your drawing thick line and thin line. Otherwise your dimension line will look like a part of the drawing, and your arrowhead should be should follow the rule, etc, etc. So in this video we have seen what are the rules to be followed in technical drawings or engineering drawing or engineering graphics drawings. So if you have any doubts or comments, please write in the comment section. Thanks for watching. Bye. Thank you.